All right, so thank you everybody for coming tonight. We are very excited. This is our first official joint DevOps and IoT event. This topic had been coming up a lot lately, and so we thought it came up a lot, but everyone we talked about said, that's really exciting and we want to learn more. So we figured this was a great opportunity to pull together some of the people that have been doing it and have them come and talk a little bit about their experiences, what they're doing, what they have done, what they're still learning about. So before we get to that, I want to just go through a couple of slides here. I want to thank our community sponsors, there's a lot. Ericsson, Mappers, PTC, PwC for IoT, Carbonite, Gemalto, Rally, and Uno Square for software dev. Where's my thank you? Oh, I think I missed my thank you to Xively first. Huge thank you to Xively for hosting us in this beautiful new building. 2 months, right? January it opened. So thank you for providing the space, our moderator. All right, so now I'd like to introduce Paddy Srinivasan, who is General Manager here at Xively. He's also a member of the IoT Steering Committee and has been very involved in helping us plan over the last couple of years and is going to be moderating tonight's event.
Thank you, Sarah. It's a pleasure to host this panel this evening. It's a topic that's very near and dear to my heart for both personal as well as professional reasons. It's probably my fourth time building a monitoring and management product, and it's really amazing to see how the new industry of IoT is actually taking to this and how DevOps is really influencing to a large degree how devices get rolled out and managed and monitored. So this panel, what we are intending to tackle is, first of all, let me introduce my panelists before we go into the detail. So I would love to just have our panelists step forward to the stage so that I can kick off the introductions, please. So we have 3 panelists, but only 2 microphones, I see. But we'll make do with that. So gentlemen, why don't you go ahead and take your seats. So as I explained, this panel is going to look at the impact of DevOps or the discipline of DevOps in the emerging industry of IoT. And I'm glad to be joined by 3 experts from companies that really have a big impact in how IoT is being shaped right here in Boston. So first of all, I would like to introduce Brian from Digital Lumens. So I'll let each of the panelists introduce themselves and also not just give a quick introduction about your company, but also outline why DevOps is really an integral part of how you conduct business in the world of IoT.
Good. Hello. My name is Brian, and I was told to point it this way. Digital Lumens manufactures intelligent lighting systems mostly for industrial space. And here's a typical installation. You can see in this picture there are over 100 light fixtures visible. Each one of those is a thing, I guess is how we would refer to it, a managed device in our network. And these facilities are hundreds of thousands of square feet. They're extremely large, require very large networks. We started out in cold storage about 8 years ago because freezers were where LED lighting was most efficient and most competitive. Now we're basically everywhere in all industrial space, all manufacturing, warehouse, etc. Where does DevOps play a role? When I started out at Digital Lumens, our DevOps strategy was we hired veterans, and they would put on their dirty boots and they would go to facilities like this and get on a forklift and touch every single light fixture with an update, touch the equipment at the facility. And now we do as much as we possibly can remotely. We do mass updates to add new features, et cetera, to these fixtures that are hung 40 feet in the air.
That'll be an interesting topic to get into, how the veterans or the people as a service or managing DevOps has evolved over the last 8 years. So welcome, Brian. Thank you. So next up is Daniel from Vecna.
Hey, thanks for having this event and hosting. For those who are not familiar with Vecna, we have a whole range of robotics products. We also have a whole range of medical products that are also relevant to this topic. But one of the things that's really important to us is scale, and we have robots deployed all over the world. Your biggest cost very quickly becomes maintaining and managing those things that are spread all over the place. And so figuring out how to do that efficiently, how to do rapid updates, get code out there quickly while minimizing potential risk or impact. Some of our robots are relatively small, so if they were to bump into something or someone, it's not a big deal, but some of our robots are big enough that they could do a lot of damage if there's a problem. So you have a little bit of a challenge there of how do you roll out things quickly and effectively and frequently. How do you also do it safely and robustly? And so in some sense, there's a lot of challenges there in applying a very rapid DevOps type of model. But the benefits of figuring that out and the benefits of doing that really span the entire business in terms of cost and competitiveness, et cetera. So a lot of interesting things to talk about, I think, here.
Okay. Thank you, Dan. Steve from Zipcar is our final panelist.
Hi, I'm Steve Vance. I'm the director of new platform at Zipcar. Most people probably know Zipcar. We are the world's largest car sharing service. You probably see our little cars with the green Z logos all over the place, pretty much wherever you go in North America and oftentimes in Europe. You could make an argument that Zipcar is one of the earlier plays in Internet of Things. We've had cars that have been connected to the Internet for close to 15, 16 years now that communicate back, and we try to make the experience as transparent as possible, so a lot of people don't realize how much is really going on behind the scenes there. But we have embedded hardware, we have firmware in the cars, and that does a lot to mediate the interaction to make that experience transparent. We're looking at multiple generations of hardware. The new platform in my title is actually about the upcoming next generation of Zipcar's underlying experience that we hope to make such a seamless transition, and maintaining a fleet of 16, 20,000 cars in a way that may be subject to variations in cellular coverage, parking in underground garages. You don't want to lock people out of the cars. You don't want to make it so that, hey, I got to my destination way out there and I can't get back in. So it leads to some interesting challenges and interesting considerations that I think we'll find a lot of similarities and a lot of differences. On the DevOps front, we're moving faster and faster toward very frequent deployments, continuous delivery on the software side, and have a bit more measured approach on the hardware and firmware side that we'll talk about.
Well, that's a great segue to the first question that I had, and maybe Steve, we can stay with you, which is DevOps as a discipline has evolved over the last 5 to 8 years, right? So it really started as a catalyst when cloud initially came, cloud and the notion of software as a service. In your experience, how is DevOps in the world of managing software that is actually residing on a piece of hardware? How does that change the discipline of DevOps, and more specifically the notion of continuous delivery, for example?
A lot of the principles apply, but it's still, you have to take into account the risk that oftentimes it is harder to roll back. If you consider our mobile phone devices as part of the Internet of Things, you're subject to the release cycle of an app store But even when you're talking about cars, it takes a certain amount of time, especially over a slower cellular network, to distribute the software, to do the verifications, to make sure that it took, that you didn't break your device and lock people out of the cars. And so it makes sense to do that in sort of a measured pace, a lot like you do with canary testing in more of a production and delivery kind of environment.
Right. So essentially what you're saying is, as this software goes into a piece of hardware, you have to be a little bit more careful because the ability to roll back compared to a piece of software that is residing on a web server, there's the rollback procedures, for example, is a lot more complicated. And one of the things that Dan, you mentioned when we had our prep call was not all of your devices are always connected. So that adds another wrinkle to this notion of continuous delivery of DevOps. So.
Yeah, I mean, if you could count on your devices always being connected and always having access to them, that certainly simplifies things a lot. But when you've got this challenge of the device may be accessible, it may not be accessible, you don't know the next time it's going to be accessible, you have to get a little more creative in terms of how you manage updates and rollouts and pick who you use for the canary testing and what customers you have a closer relationship with to really verify that your updates are going to be a positive experience for the majority of your customer base. Because I think we've all experienced when an update ends up being a very negative experience, and that's not something that we ever want to do to our customers, particularly today where customers can be very fickle because there's so many options out there. You give them a bad experience once, you give them a bad experience twice, you've lost them. And so we really need to make sure that you balance the risks with the benefits and make sure that, DevOps really at the end of the day should always be about providing a superior customer experience and doing that at a lower cost and doing that more effectively. So it's important to, not get too excited about the development side of it and forget that the goal ultimately is to provide a superior service to your customers.
Dan, do you worry at all about the robots having bad experiences and getting unhappy?
The nice thing about robots is that they don't, I guess I should use good words. They don't really care. So that's one of the, and I think robots, things, technology, computers, in the coming decades, all of these terms are going to converge. You're not going to care whether your phone is considered a robot or a smart device or a thing in the Internet of Things. It's all going to be connected, and it's there to work for us. It's funny actually because about a decade ago, my wife, who's the CEO of Vecna, got invited to speak at a conference on robot ethics. And they were very concerned, this was mostly philosophers, they're very concerned about the robot's rights. And they said, if you can't prove that the robot is not sentient, then the only ethical thing to do is assume it is, and therefore it has rights, and we should make sure that we're very nice to them. Okay, no silly, guys, no silly.
Dave?
It's interesting, talking about the customer experience as it relates to DevOps, one of the important things we're realizing is that the metrics that you use to determine what kind of experience you're giving are very, very different. So for example, on our software side, we can emphasize mean time to recover. Under the idea that things are multiply provisioned, we may have degraded service and so on, under the assumption that if you can recover fast enough that nobody notices, you're essentially not out. But when you get Internet of Things, you're looking at a device that does not have any redundancy in a lot of cases, that doesn't have, that's pretty much either on or off for the most part. You may have something that's a glitch, and it really comes back to how do you measure the availability that it has to service the customer's needs. And it's an entirely different set of measurements. It really comes back down to a lot of traditional, crash rates, mean time between failure and user satisfaction.
So Steve, that's an interesting point. So can you elaborate a little bit about how you have set up your rollouts of the continuous delivery pipeline. In terms of, you mentioned that you have some test hardware, and then you have some real hardware, so simulation hardware, then you have real hardware, and then you have friends and family or test deployments. So can you elaborate a little bit on that? Because I think that would be really useful for the audience.
Yeah, so we have, first of all, just for bench testing and testing for software integration purposes, we have these harnesses that can just plug into a laptop, and over the USB they emulate a car. Have little lights indicating whether the ignition is on or off, whether the horn honks, the lights are turned on, whether it's locked or unlocked. And that is how we make it widely socialized, and what we integrate into, what we're looking at actually integrating into our sort of more continuous delivery pipeline in our newer architecture, to get a much broader set of exposure and integration testing before we really start getting into cars. And then we have R&D fleets. We have cars in Boston, San Mateo, London, I think Miami, and New Jersey at least, that are R&D cars that then get over-the-air flash next. And so we've set our over-the-air so that we can do a broad-scale mass over-the-air update, but at the same time we need to make it so that it's selectable and addressable to a limited audience so that we can do this. And so for these purposes, I was just out in our San Mateo office a couple weeks ago, and I pretty much just used one of those cars and the test version of our app to do the BLE login, and use the card to get in, and used it to get back and forth to my apartment. And then we have different selections that we do based on either friends or family or certain people in the field that need to get experience with new features, new capabilities. And then even then, when we're finally rolling it out to the general population, we'll roll it out in waves so that we can look for upticks in member service calls related to vehicle behavior, whether or not it disrupts cellular communication, carrier communication, and so on.
That's fascinating. And what typically do you measure when you're doing these incremental rollouts? How do you know that a rollout is ready for prime time?
Well, the very first is, on the desk, on the bench, you have, does it operate well with the harness? But when we start monitoring when it gets deployed out in the field, we have these ping and aliveness protocols built in that let us at least know, is it healthy enough to talk to us? Is it healthy enough to respond back? Can it check in? Can it respond to certain events and queries, fuel level, and things like that? And so those act as a first check. And then you start getting, and eventually we get to the very responsive, reactive end of things, where it's like, oh no, member services calls are an uptick regarding vehicle login, vehicle access. Something might have gone wrong that we didn't catch before.
Okay, makes sense. So Brian, I'm going to come back to you since we haven't heard from you for a little while. So I want to switch gears a little bit. So your customers are not end consumers, right? Your customers are typically manufacturing facility or logistics distribution warehouses, and they're very geographically distributed, and not all of them are connected at any given point in time. So having this ability to remotely update devices and monitor them and manage them using the principles of DevOps, what kind of benefits are you delivering to your customers? Or if you were to interview one of your customers, what would they say about the service you provide and your ability to keep the software and the hardware updated and deliver new functionality?
I would say that the best strategy there is to get it right the first time, so you don't have to go back and do a lot of updates. That hasn't worked out for us yet. But that's what we strive for, is when we show up at a facility that we're delivering a complete function, a complete set of functionality. What we have done in the past, we have added new features to the firmware and the lights and the software and the management system. And at that point, it's kind of a seesaw. It's kind of we want to convince the customers that there's new value, and then go through the process of deploying the new code or whatever.
It makes sense.
I do want to underscore a little bit something Steven said in terms of the knowing when there's a problem. So about 2 decades ago, we started to pretty aggressively deploy kiosks, similar to what's in the airports for checking in for flights, but we were doing it for the healthcare industry. So we were deploying these kiosks to hospitals all over the place. And what I realized early on was that the most important thing for us was making sure that that kiosk was up and available. It was surprising to me that the customers didn't care, and I suddenly realized it's because, well, the customer cares, but the people who are there on the ground, the workers, they don't care. They're happy to just slap an out of order sign on it or whatever. Oh, thing never works. And so it became very important for us to be the first people to know if there was a problem and to be able to take action. And at that time, we had ability to update things remotely, but it was still a very significant process. We're talking 2 decades ago, pretty risky. But the most important thing for us was, is the device behaving, operating? And our goal was always to make sure that if there was a problem, that we resolved that problem before the customer ever even knew that there was a problem. And that's sort of been the standard that we've tried to build our products around. Very, very important. So I'd say, don't jump to the pushing stuff out stage. The very first and most important stage is getting that information in and making sure that you've got that information, that knowledge. Because otherwise you can sort of put the cart before the horse and create a lot of problems and have a lot of unhappy customers.
That's a really interesting point of view. So in your operations today, how many of, or what percentage of your updates are reactive to a problem that you're noticing compared to a proactive enhancement of a given functionality or enhancing the hardware capabilities that are already there?
Well, so I'd say to a first order approximation, the vast majority of the problems we end up responding to are one-off hardware problems with a particular device. There's some, just statistics, there's some failure on a particular device, and being able to be aware of that. And obviously that also helps us in designing the devices in the future in terms of what components are causing us the most problems. There have been widespread challenges. Sometimes, for instance, we have a lot of kiosks deployed throughout the Veterans Administration, and sometimes the Veterans Administration decides to update other software that we're dependent on. And so we've had to do hot fixes very, very quickly and roll stuff out across thousands and thousands of kiosks. And it's always a little nerve-wracking.
Well, that makes a lot of sense, and I think you're making a very profound observation here, if I may add, which is DevOps in the world of IoT, when hardware is involved, is not just one way, because DevOps in the software or the SaaS world is typically, okay, you pushing, or the platform provider or the software provider is pushing updates to the software. But what you're saying is, in the world of IoT, it goes both ways. You need DevOps to be a monitoring, need to have monitoring capability, at the same time also have the continuous delivery and the software update capability.
Yeah, we called our system Pulse, and the idea was that every single device out there is proactively sending out a pulse to us that we could monitor and know what was going on. And it worked out fairly well, because, specifically because we made it so that the device was pulsing out rather than us trying to connect to it. We bypassed most firewall and security issues and that type of thing. We just had it send out a little HTTP put or get or whatever, and it would just tell us its status, and really simplified things for us.
Great. And Steve, from your perspective, do you also practice DevOps as a bi-directional mechanism, where it's not just push, but it's also pulling system information or the current status of a connected car?
No, absolutely. It's actually part of the protocols that we've designed are built in. Am I alive? Am I healthy to a certain extent, and so on. And keeping an active monitor on those right at the gateway that ingests the event from the vehicles is a really important part of us understanding what's going on. And there are many times when, even when it's not a problem with the vehicle firmware itself or the vehicle hardware, we actually know other symptoms about things going wrong in our overall system because it shows up in the vehicles first because of that monitoring.
Okay, makes sense. So I'm going to switch gears now to talk a little bit about the process and the people behind DevOps in your companies. So I'll start with Brian. Do you have a notion of a dedicated DevOps group at your company?
We have a notion of that person, but we haven't hired that person yet.
So who actually fulfills that obligation today?
So, as I understood the original definition of DevOps, and my background in the networking equipment business, I was a developer, and then I would go visit customers, and they had a network engineering team, and they were the most hardcore, badass guys I have ever worked with. Every time I would go to UUNet in Virginia, I would just get completely beaten up by some of the most just hardcore, awesome engineers I've ever worked with. And that was a really formative experience for me to know what it's like to be on the front lines and to see systems fail in mass. And a lot of engineers, a lot of software engineers in particular, spend their careers isolated from that sort of world. And so, as I understood DevOps, you break down the wall between development and the people responsible for the operation state of the network, and you share that responsibility. And so for us, the answer is we do all of that. We don't have a separate team from engineering or inside engineering that's responsible for operations. When we build new products, we're responsible for deploying that through continuous integration, continuous deployment, and getting it all the way to customers. That's really our responsibility as engineers.
So it's a shared responsibility across multiple teams. Makes sense. What about you?
Yes, so one thing that was important for us is to have somebody who is specifically focused on not being in the day-to-day grind and having that higher level perspective and looking at what we're doing with respect to DevOps and how can we do better. So we specifically pulled somebody out and gave them the freedom to be a little bit more innovative and explore, look at what we're doing from a third-party perspective and say, is this right? Is this achieving our goals? Because when you're right in the middle of it and you're focused on dealing with the next problem or the next challenge, you don't always have the discipline to really take that long view and, are we using the right tools? Or are we just using the tools that we've already always used? Do we have the right team structure in place, or did it just sort of happen? Those type of questions. So that was really important for us, is to make sure we had somebody that had the freedom to look at that, examine that, ask questions, and propose new approaches for doing things. On the flip side of that, for me, it's always been really important to not get too tied up in the religion of any particular movement. We had some real problems actually when Agile was, hot on the scene and it was this great new thing. Because we had a lot of engineers that got really religious about it, and it was always about, well, what are you supposed to do in Agile? Let's do that, rather than really turning on their brain and saying, what is going to help us produce a better result, and does this make sense for us or not? So I think that's a really important aspect of it, is to not blindly try and apply some principles we read on the internet or anything like that. DevOps, Agile, all of these things is about really doing what makes sense in your particular situation, rather than trying to apply some cookie-cutter recipe that's going to magically produce some results. The magically producing results thing never happens. And oftentimes you can do more harm than good coming in and trying to apply principles in a way that doesn't really work for your organization. So I'd say that that's been the most important organizational aspect of it for us. In terms of the actual teams, one of the big things we did was made everybody sit together. So, we have the systems people and the QA people and the engineers and the project managers now. Those people sort of used to be in their different areas, and now the teams are more co-localized, co-located, thank you. Didn't get a lot of sleep last night. I was working on DevOps stuff. But yeah, so.
Well, I think you hit upon a fantastic point there, Daniel, about the fact that DevOps and Agile really are about doing what works best for you. They're not a prescription. If you are following them as a prescription, you're probably doing the wrong thing. In our case, we're very much in, I would say, a state of transition. We have a DevOps team that has sort of the primary operational responsibility for a lot of the network and deployed software, and especially the hardware. And we've had a rotating on-call responsibility that comes out of engineering to support that on the software. So that's a fairly traditional approach to it. On the other hand, a lot of our firmware engineers are actually the ones who know absolutely first what's going on in the cars and are most tightly integrated with that. And with our new platform, we're moving to a full bore set of continuous delivery tools based on Concourse and Bosch. And the developers, in tighter collaboration with the people who have been in our traditional DevOps team, are really collaborating much more closely to design the monitorability, the maintainability, the supportability, the deployability of everything, whether it be the firmware or the software, much more upfront in integrating that in, and the developers are getting involved in crafting the continuous delivery pipelines and the checks in there, and it's a really close collaboration, even when it comes to moving things between data centers and so on.
So Steve, you touched upon this just a little bit, but can you slow it down for the audience in terms of the tools that you are using? I think it'll be really interesting for many of us to learn what tools do you use for continuous delivery, monitoring. Did you build your own, or are you using off-the-shelf tools for that? It'll be great to hear from all of you.
So what we're doing, and I'll talk about for our current platform, it's Puppet Enterprise, a lot of fairly manual scripting, but using the templating that we can get from other sources where we are using things that are conventional. Some of our older pieces of our stack have nothing conventional. We've had to roll our own in that frame. In the newer platform, we're using a self-selected subset of the Cloud Foundry stack. So we're using Concourse for the continuous integration, continuous delivery, and we're setting up a collection of pipelines where applications have their own individual pipelines that then converge up to overall integration pipelines leading out to the deployment. We're using Bosch to do the infrastructure management. This is all part of the overall Diego suite of things under the Cloud Foundry collection.
That's very informative. Dan, from your point of view,
Looking at my cheat sheet here.
so can you talk a little bit about any tools or methodologies that you might be using in
Yeah, so just to make sure I had it all up to date, I just sent a text message to my DevOps guy to ask him which tools we're currently using. And so he says, and I just need to be ambidextrous here. All right, continuous integration with Jenkins, code review and commit validation with Garrett, Docker for environmental consistency, upgraded processes tested with continuous integration. And then he says in-flight blue-green deployments for code and infrastructure, bring up a new server, test, migrate the new server, deprecate old server. So all that and more.
Brian, would you like to?
We use all the same stuff. So we're in the process of moving to a Docker-based infrastructure. Docker has a lot of great advantages because you get control over an environment, so you know that one developer's got the exact same stuff as another developer through your CI and out into the field. We're not using Docker in deployments in the field. It's all mostly during the whole development process. We're also using CodeShift, which is a continuous integration platform, and they're based right around the corner here on Atlantic Ave. And because we're in the energy management business, we're in the green tech world, we only use locally sourced, artisan crafted, continuous integration systems.
Makes sense. So one of the things that I want to share my perspective, because this is what we do for a living, and we talk to several customers. The difference is that all these three companies have been doing a variation of the connected product for several years now. And one of the observations that I have, especially working with companies that are just starting the journey now, there are more and more off-the-shelf tools that are available that can be readily brought into the system environment without having to invest in building a lot of these things, especially for the monitoring and management of these devices from a remote management point of view.
We just did our 8th anniversary of the company this last week. And I think if you had asked me that same question 6 years ago, I would have looked at my phone and said, Mike says bash. That's our tool set.
Right. I think it is continuously evolving, and we feel like that's a big opportunity for not just companies like us, but also professionals that are in the DevOps world. Because if anything, this is only going to get more complicated, and these devices need more babysitting, and these are not traditional web applications. So the other observation that I have is, it's also really interesting to notice that almost all of you said that DevOps is not a dedicated discipline, but it's a shared responsibility across different business units or different disciplines inside your organization. That's certainly something that we are seeing as well, in terms of the same person wearing multiple hats. One day he's testing a new firmware, second day he's rolling it out, the next day he's also responsible for monitoring the fleet operations, making sure that everything is fine, and also handling the escalations when something breaks. So that in due course of time, as with most industries, it will probably settle down and it will become a dedicated function for most companies. But certainly at this point, it seems like a shared responsibility.
Can I ask you a question? He didn't ask me to ask him this, but what does Xively bring to the table that makes this easier?
Great. That was not a planned question, but without boring everyone here, I can shed some light. So Xively, we call it as a connected product management platform. So Xively's value proposition to product manufacturing companies like some of you is, it makes this whole process much more easier and more streamlined. So we provide not just the ability for building connected products, but also monitoring and managing them and supporting them once these devices are operational and out there in the field. So that companies that are just embarking on the journey that you started several years back don't have to go through all the painful steps that you had to go through because there were no tools or these capabilities were not streamlined. So I want to switch over to the last topic, or the last main topic before we open up for Q&A, which is this notion of security, because we never talked about this. And when I say security, security comes in different flavors, especially when we start talking about hardware devices. There is also a notion of, in traditional DevOps, you're only laying your hands on your software and your hardware. But when you start talking about devices that are now being deployed and software that resides on these devices that are typically deployed at your customer sites, this notion of DevOps being responsible for continuous delivery has far-reaching implications, because you're not just touching your stuff, you're actually impacting what is really happening at your customer site, whether it is a shop floor, an assembly line, or something which has much deeper business impact for your customers. So I'd like to start with Ryan. How should we start thinking about this notion of security and also access ownership for changing the software that resides on physical devices?
So the security issue is interesting because I believe it was a year and a half or 2 years ago, there was a security breach at TJX, which is another local company out in Massachusetts. And what happened was intruders gained access into the system by way of an HVAC system. So they were able to get at the company's network through an HVAC vendor, actually. And so that put us in the spotlight as a lighting services vendor, as a lighting systems vendor. We're a potential vector for attack of our customers' core systems. And everyone became aware of that, and everyone started asking us questions. We have customers in the aerospace industry, and of course they were already well aware of this. And so So they don't allow us to connect to their backbone network. They don't allow remote access at all for our systems. But that's an important part of it, is that we have to take responsibility for our customers' network, and we have to treat security seriously. Early on in our history, the sales engineers would come to us with a long list of questions from a customer like Chevron. They would say, there's 150 questions here, we have no idea how to answer all these. And we took a cue from the first applications engineer that we worked with. Aaron Kless was a nuclear submariner, and so he was prepared for pretty much anything. And one of the first facilities that we went to was a refrigerated facility, and we showed up there with our sneakers and our laptops, and they said, stand over there behind the orange line, and don't go anywhere, don't touch anything. And Aaron said, this isn't right. So the next time we went back, we had refrigerate, which was like industrial parkas and pants, and we had the company logo on them. We had hard hats and high-vis safety vests. And the facility manager said, there's a lift, go to work. And so we learned that being prepared for what the customer's expectations were was a huge part of how you engage. And so what we did is we put together a very complete disclosure about everything that we did with the software in terms of which internet ports we used for what traffic was going where, who had access to the data inside of our company, what we used the data for. And so whenever people came to us with this long list of questions, we would say, we understand your concerns and we take them very seriously, and show them our report. And then they would say, okay, that's great, let's move on to the next thing.
Yeah, that's really fascinating. So now you have a recipe of all the network implications, the access control, the data that you're capturing from your customers, how it is stored in your system, and who has access to that. And that becomes a manifest that you give to your prospects.
We don't give it to everyone. We don't have it posted on the website, but certain environments, we know this is going to be an issue, and we want to approach the conversation well prepared. We want to walk in there fully dressed for the conversation, and have the facility manager or the IT manager say, the lift's right over there, go to work.
Makes a lot of sense.
I guess I need to correct something I said earlier, which was nothing can put you out of business faster than not having a good customer experience. It's a security incident, and this is something that is just so crucial to be careful about, particularly for us. Our systems have access to a good portion of the healthcare data in the United States, that's obviously very, very serious responsibility, and so making sure that that is always at the forefront of everybody's consciousness when you're thinking about putting software out there. I had a low experience the other week. I wanted to take advantage of one of my own products and be able to telepresence into my home with our Vigo robot, and so took the robot home, set it up in my house, and then just the other day I was sitting there looking at it, like, you know what? Anybody who has access to the system could just pop into my house now. And how much trust do I have that this technology company is going to, have proper security in place so that that's not going to be a problem? And there's real security, and then there's also the perception of security and trust, and I think both are equally important, and one certainly has a big impact on the other, but yeah, incredibly important area.
So how do you translate that to access privileges for your DevOps team? Like, do you have a much more restricted list of people that can actually push code into the continuous delivery pipeline? How do you maintain that?
Yeah, in practice we actually do, although thinking back, I don't think the decision around that was explicitly around security. Because we do government and healthcare, we have significant security audits we have to go through, and background checks and all that type of thing. So in some sense, maybe we were just resting on all the stuff that the government was making us do anyway. But yeah, it's an important question. I haven't given it thought at that level, and it's probably worth some attention. Yeah, who do you trust, and do you really trust them with everything, or do you put some checks and balances into place? Have the old Cold War two people with keys thing. I don't know. What do they do with cars?
Actually, let me touch on some of the compliance. Touch on some of the compliance and regulatory issues right now. For example, Zipcar is owned by Avis, has been for about 4 years now, and as a larger parent organization, they are publicly traded, very attentive to things like SOX compliance. Because we process payments, very attentive to PCI. And there are traditional controls for that, but we are actually in the process of renegotiating the whole control protocol in order to accommodate our desire to move into a more aggressive continuous delivery space. And so where you have a lot of traditional controls that have relied on everything from having opposing parties that monitor each other to multiple levels of approvals, the 2 keys to launch the nuke, that kind of thing. How do you compensate for that? And so, some ideas is we're actually building into our continuous delivery pipeline things to check some of the more automatable compliance issues. Do we have a different developer and tester and approver on each of the different things that have gone in? And just make that automated, since it's all part of the way that we process the work through the people anyway. But that also requires, since we're having developers get involved with the continuous delivery pipeline, how do we make sure that they didn't turn it off? So we also have to have these sort of untouchable watchdog things to make sure that the compliance is still intact. So anyway, I just wanted to touch on that really quickly. And we're a little bit different, I think, in terms of the actual security of the device, in that we own all the cars, and they're not plugged into someone else's network. That said, they are free-floating. There is a good value. If any of you have read the papers, especially around San Francisco, you may know that over the last year or so, there has been an organized ring of people stealing high-end Zipcars by figuring out ways to bypass the hardware. And it is an ongoing battle.
Have you done a booby-trapped one yet?
Yeah, not quite that. Not quite that far, but so in the San Francisco area, there was one lady in particular who was responsible for 30 plus cars, all of them BMWs, Mercedes, and Audis. And it has a serious impact on the bottom line, and it has caused product and procedural changes that I really can't get into.
No, that's really fascinating. So in recap, before we open up for questions, I think one of the things that this panel has shined a light on is the fact that DevOps is a very, very important part of connected devices, or IoT. It is still in its infancy in terms of being able to address all of the challenges of running a connected devices operation. And one thing we know for sure is that the notion of DevOps, the skills of DevOps people, is only going to escalate dramatically because of the fact that most product manufacturing companies are not software companies, but they're trying to do something which is extremely relevant to the skills that most people here in the audience bring to the table. So it's a moving target, but we're seeing based on your multiple years of experience running devices that are often connected or mostly connected, I would say, there is no shortage of challenges that have to be tackled. And there's no standardization in terms of tools and processes and security. The only thing we know that is constant is the fact that you have almost a higher level of consideration in terms of security, privacy, and data ownership when it comes to actual physical devices. So I think it's a great opportunity for professionals that are in the DevOps domain. and it's going to be fairly relevant for the next 5 to 10 years, I would say. So with that, I would like to thank the panelists. I think it was really, really enlightening. And we have some time for Q&A, so I'd like to open the floor up. I think we have a fairly small room, so I don't think we have to use microphones. So if you can please be loud, the gentleman in the back, please.
Yes, my name is Timothy Reeves, I'm with the License Group. One quick statement to that my question. Well-implemented DevOps stack, you're not limiting to who is doing something, it's the auditability and under what conditions it's happening. Now the question, from a quality perspective, all of you gentlemen are in situations where there can be significant hurdles to overcome if one of your deployments goes awry. And the solution to that typically is quality. And in traditional software development, we seem to be only focusing on finding quality issues, not preventing them. And I don't mean inadequate test coverage. I mean investing in technologies and languages that prevent certain quality issues from occurring, right? Split from Apple, Ada are examples of languages that are attempting to prevent some of the more common quality defects from cropping up. In your organizations, have any of you approached or reintegrated what is coming out of your DevOps stack from a quality perspective and trying to ensure that some of these quality issues aren't possible to happen? Right, by either re-engineering your libraries, your software libraries, or your hardware, or working with the language vendors to say this is a common recurrence in quality and let's nip this in the bud.
I think that's a great point, and I'm going to think about that more. I think there's some real opportunities there, and your point is very relevant because particularly when you're talking about building and maintaining a profitable enterprise, I think we've all seen the stats on bugs. The later in the cycle you find it, there's exponential cost increase. And so how can we, I mean, ideally we prevent all quality issues from ever happening in the first place. That would be the ideal situation. And, you know, unfortunately, I don't think we spend enough time there. So I'm interested to hear more about that.
We're doing some things in that direction. In terms of bringing detection of issues closer, we're building in static analysis tools, we're putting in a strong testing regimen, including, for example, contract testing at the service interface, trying to keep things small and tight so that they don't suffer from the incomprehensibility problem that often leads to quality issues. We've also been experimenting with some of the strongly typed functional reactive languages as a way to make sure that correctness is compiled in rather than tested in. We're not very far along that quite yet. I think those are some of the things that we're doing that are at least sort of pushing the envelope a little bit on that, but there's definitely a ways to go.
I have no good answer for that.
Hi. Question maybe for Daniel or for others as well. How do you, because you guys are in hospitals and things like that, so very sensitive industry, how do you guys handle any kind of malfunctions or monitoring? So it's a 24/7 world out there. Do you guys actually have eyes on the systems 24/7? What happens if there's a malfunction at the software or the hardware level? How is that handled given the fact that I presume your things have to be operational all the time?
Yeah, it's a sort of a multi-tiered approach. One is that we try and not have any deployments where there's only one device, where, you know, if one device went down, that they'd be, you know, in trouble. So we try and have multiple devices available, which is usually necessary for handling the volume anyway. And then through that ongoing monitoring, if a device goes down, we've got some coverage, and then it buys us a little time to bring it back up. But yeah, we have to have access to boots on the ground sometime too. So we've got agreements with different service organizations around the world that if we absolutely have to, we will send somebody on site, usually the same day, often within, minutes or hours, depending on how far it is. But it's really important to have all of those fallback options for us. Stakes are very high.
Do you guys in general see these outside service organizations with boots on the ground or other service delivery areas as essential to your continued growth and success, or is it, like at Zipcar, you guys handle all around the world? How do you guys get it done? On-site type of stuff?
Yeah, it's essential. It's hard to find good partners in that area, I've found. We've had a lot of bad experiences where, we need somebody to go and they'll send somebody, but that's about all you can say about the person. They don't impress the customer, they don't do a good job. So, I don't know, you guys probably deal with this.
Yeah, we've entirely staffed it ourselves, and part of that is also about the brand image. It's going to be really hard to hire a service provider that does things like when the field service guy finds out that somebody is getting a car to help with their wedding, he actually shows up to chauffeur them with bows on the car. It's really hard to find a third party that'll just do that spontaneously. People who will actually bicycle around to make sure that the cars are cleaned and gassed in a tight city because it doesn't make sense to drive, and the cars are where the mass transit isn't, just because that's where they're most needed. Now we have contracted out, we're working with a company in San Francisco in a pilot, for example, to do actual delivery of car to the customer rather than them having to go to where the car is parked. So there are some places where it makes more sense. Because we design our own hardware, we tend to train our own installers. And one of the things I didn't mention earlier in terms of like the software aspect of recovery, if a car can't communicate with the network, we actually have special dongles that we send out to field service people that have the latest firmware that they can plug in and upload if they know the right incantation. And that's the ultimate human recovery, and it's not predictable enough for us to need that, for us to contract that out and have somebody always on hand to do that outside of the normal field operations staff.
I'll add to what Daniel said about the difficulty of finding good partners. We're selling physical objects in our case. It's a lot smaller than the ones that Daniel's company is selling. But you need a partner to manage the process with the customer. You can't scale your company if you're selling directly to every single customer in the lighting business, certainly. And so that's been a challenge and a limit to growth for us is the reach we can get through partners. It's really critical. On the other hand, the intelligence in our system mostly turns off the lights when no one's around. And so if we lose network connectivity, or if the server has some sort of issue on site, it fails into a perfectly acceptable state. We don't generally have failures that are that critical that require, millisecond or 1 day response time. But in those cases when we do have an issue like that, a good partner is the best thing in the world, and a terrible partner is the worst.
Do you guys do like Friday disco lights and patterns and stuff?
No.
You need to do that. That'd be cool.
So this is kind of a follow-up on my earlier question. Have you found that you've changed your hardware in any way to support it being more readily integratable into a fully automated DevOps stack? So that you can recover if an update goes awry, or to assert that it actually completed successfully?
I would say that we haven't, because we recognize the risks that necessitated the kinds of features that would support that anyway very early on.
Yeah, it's same with us. We had always been built on the Linux stack all the way back, and so our whole approach was make sure that we have the ability to connect to our device seamlessly from the very beginning. So it's been more of, maybe we got lucky in making that decision, and now it's been how do we really take advantage of that and leverage that fully to to build out our DevOps.
So it's been in software, not in hardware.
Yeah, exactly. Yeah.
I would say yes, although, again, probably more for facilitating software. But we're in our third generation of the network gateway, which is the device that communicates between the Zigbee network in the facility and the hardwired Ethernet, because you can't build a wireless network to cover a 500,000 square foot facility. And we're in the third generation of that platform, and the new platform that we're developing has Docker built in so that we can more quickly deploy full images with capability. And we're fully expecting that a year from now, we'll be deploying new capabilities that we haven't even thought of right now, and that was not possible with previous platforms. So that's definitely, we're spending more money on that hardware with the flash size and the capabilities in order to get that sort of flexibility in the field.
This is a follow-up on the gentleman's question as well as my own question Paddy asked earlier about tools. You also mentioned standard web DevOps tools, and I'm wondering how you're actually updating the end devices on the field. I think you sort of started to answer that. Have you changed these traditional web deployment tools like Puppet to be able to update the cars themselves, or are you using something different entirely?
I'll answer that really quickly. In the past, we had all homegrown tools, and we moved to some more sophisticated homegrown tools that can update all the devices in a facility remotely overnight, which was a big improvement for us. And then we're moving in the future to using tools like Puppet, although we're not really Puppet fans, but Docker and things like that. We're moving in that direction to use more industry standard tools because you always get more efficiency. It's easier to hire people than here's a weird bash script that Mike wrote and then left the company. Try to figure out what it does.
Yeah, so from early on we had it so that when our device would boot, it would have a local OS on a memory stick or whatever the flavor du jour was. And then it would immediately check and see if it had the latest version of the software. And if it didn't, then it would download that software and then automatically install and reboot. That worked pretty well for us. Now that's a heavier weight device that's really running a full operating system. But even our much lighter weight devices, for us, we tend to run full operating systems, even if it's Raspberry Pi level of Linux. We've just found that simplifies things for us, but that's probably not appropriate for a large portion of the new IoT that's going on these days.
So if there's no user interaction there, would you say that the remote fleet is evergreen? That they're always pulling updates?
Tend to always be running on the latest version.
So we have definitely rolled our own for the most part, and it's definitely still done in a push model. It's triggered a little bit when the vehicle checks in the middle of the night, and that's part of how we manage some of the rolling. That's also part of the signal that we use, like if the vehicle is parked underground and can't get to the cellular network. But part of what we've done to simplify a lot of this is we've made sure that the underlying protocols too are simple yet extensible, so that it's really easy to it doesn't force us to redeploy as much. We aren't running a full operating system. We have yet to find a full operating system that won't just kill a car's battery if the car isn't used for a couple of days. Just to give you an idea of some of the challenges. And so we're definitely doing a push. It is tightly integrated into our software. We wrote it ourselves because it does tightly integrate also into some of our inventory management. So which hardware ID is in which car, has which capabilities, and so on. Because we really do have to integrate into a wide range of vehicle makes and models, which adds to the complexity of being able to integrate with the car's functions.
based on all of your experience in using DevOps and Internet of Things, so what are the reasons for which you have considered changing the tools and software platforms following your DevOps? So were there any problems faced by customers that originated because of the tools used in the DevOps environment?
I would say a big one for us is just time to market. That's been a huge one. Needing to change our traditional development process to something that would allow us to be more responsive and not spend all that time and money pushing out a next release. So that's probably the biggest one for us, is how can you get it to them better, faster, cheaper.
Same here.
Hi, Jason Roder from Powerhouse. I have a question and contribution. The question is kind of a broad one, which is, how is the implementation or the advent of DevOps impacting the product management function, if at all? What is that interaction? Where is that kind of going? Is there more interaction? Is there less? And then the contribution is just to build on Brian's response with the TJX thing. We come from the energy management world also, and it was the invoice system at Target that was hacked from a password that an HVAC vendor happened to have.
Yeah.
So it had nothing to do with the HVAC equipment as an IoT device. But the press didn't really figure it out. Anyway, the question is, product management, DevOps, how is that coming out?
It's definitely raising the bar on the degree to which availability and monitorability factor into the product definition process in order to make sure, to your point earlier, that the quality as it manifests in those characteristics is understood when it's being built rather than as an afterthought. And it's been, it's an adjustment, I think, for the product management world to think about that, because some of it is a lot more technical, perhaps, than sometimes is dealt with, and it's not necessarily a user experience, feature-oriented kind of thing in the same way that, you know, how does this button look, or how does this interact?
Yeah, it's a great question. I don't know that we've ever gotten product management right. That's been one of the things I've personally struggled with for decades, in terms of how do you really pull that all together in a way. You know, there's sort of this expectation, there's a product manager, and that product manager is supposed to sort of have their fingers on the pulse of all the different pieces. And I haven't found a person that's actually capable of doing that yet. I think it's maybe too tall of an order. So we've sort of maybe done more of a distributed product management approach where, yeah, we've got a product manager, and the product manager is nominally responsible for the overall thing, but a lot of the functions that you would typically ascribe to a product manager seems to be more shared responsibilities in the team. And also, I think that spreads out the risk too. So, I don't know. It's a non-answer for your question. You're welcome.
I have an opinion to chip in with on this specific question. I think it's a great question. And we are seeing a lot of cross-pollination in terms of not just product management chipping in with DevOps, but also other disciplines. For example, mechanical engineers. Brian alluded to the fact that one of the things that is happening more frequently now is hardware is now shipping with capabilities that are not fully unlocked by software, and using the power of software upgrades and DevOps, you incrementally start unlocking new functionality, and Tesla is one glowing example of how they automatically upgrade the car when you're sleeping. We're seeing that even in trivial things like an espresso machine, for example, you get new functionality without upgrading the hardware. So that really has to be driven from product management or any discipline that really touches it, including like the electrical engineering or mechanical engineering. All of those disciplines have to contribute and work with DevOps to make that happen. So I think that convergence, we're beginning to see that convergence of disciplines leading to continuous upgrade of both hardware and software functionality. And last question.
just a general question around standards when it comes to IoT. There are all kinds of different standards, whether they're platforms. For example, PTC has their own ThingWorks. Where are things going? Just putting your futuristic hat and thinking ahead. Are we going to see a standard around the IoT side? Are these platform as a service? Is that an avenue to avoid the standards? What do you see the future for IoT?
I know that we have to do a lot in terms of complying to the standards for the electrical devices, especially as they're embedded in the cars. And we not only have to worry about that within the US and the rest of North America, but also European certification as well. And as we expand geographically, that'll probably be more of a challenge. Right now we have everything from cars in Hawaii, all across the US and Canada, going into UK, Spain, France, Germany, and a franchise in Turkey. And that footprint is only going to expand fairly rapidly. In terms of the standardization of the platform, I think what we're doing is, at least for the time being, we haven't really found a standard platform that supports our needs because of certain constraints. You know, anytime I hear that, I have a certain amount of skepticism. So hearing myself talk, I'm like, we must be missing something. But I'm sure that it will converge. I just don't see it happening quite yet at least in some of the areas that I have to deal with. You know, you look at things like Arduino, Raspberry Pi, some of those, there's definitely some convergence happening in those areas.
Yeah, and I think it'll be selective. I mean, I think we'll start to see things that people will be able to take for granted and not have to reinvent that. You know, when somebody does it and they do it right and everybody will just take advantage of that, that tends to be how the standards are effectively implemented. It tends to be more of a pull than a push in a sense. But I believe pretty firmly that the term Internet of Things is probably not going to be a long-lived term. It's because of this convergence. We're going to expect that every piece of technology and things we don't even consider technology in our lives are going to be connected. They're going to be able to respond or be updated or whatever. It's just going to happen. And so, yeah, that's only going to happen if people start taking advantage of common services which are based around standards. So, I mean, I think it's inevitable. The question is really just timing.
I'm afraid that's all we have the time for this evening. To my fellow panelists, thank you very much. It was really, really enlightening. You've given us a lot to think about, a lot of sound bites. And I think there's many more discussions to be had around this discipline. In a nutshell, I think DevOps is really relevant, and we're only scratching the surface or the tip of the iceberg in terms of the impact DevOps can have on IoT and the emergence of different challenges in IoT. So thank you again, and thanks everyone for attending.